Hello guys, here's just an update for the timers. That updated code. I finally found my microphone. Hooray! Anyway, here's an update on the code that I did. Basically, what I had to do was this tris-C. If you see this, that's setting up your tri-state registers like we always do. This is how you set them up with the high-tech C compiler. Normally you do that that set tris thing, but this one you just say tris-C or tris-B or tris-A, whichever port you're wanting to set up. And in our case, we're just setting it all up for output. And then here's that analog select. You have to select all the ports for analog mode. That's what I was talking about. I can show you it on the data sheet. Give me a second. Let's see. Okay. Let's see. Let me grab it. Okay, here we go. Alright, so I got the data sheet. If you go to analog to digital converter module, you get this whole deal. And if you notice, they talk about the AN select registers down here. They show that that's one of the available control registers. If you scroll on down, you have the ADCON 1, you keep going, and here it is, AN-SEL. And what this is the analog select register, and as you can see, here's all your bits for your analog ports, because you have an 8-port A to D. So you're going to look at analog select between analog or digital functionality. And so basically, if you set the bit as 1, you get analog. If you set it as 0, you get the digital. So the thing is by default, these are all 1s, so it's all analog. So if you want to do any type of GPIO or anything like that on these ports, then you're going to have to tell it to do digital ports. And to show you another thing, I don't like it when you click Adobe Zooms. Alright, if we go back up and we look at the actual device overview, let's see if we can't scroll down. Okay, here we go. On this guy, we're using in our deal, let's pull up our deal here. We're using RC0 and RC1. Those are analog. Those are AN4 and AN5. Notice that? So we're down here on 676. We're using 0 and 1. That's 4 and 5. So basically those are by default set as analog ports. Well, we're wanting to just blink some LEDs with them, so they need to be digital, where we can just flip them high and low. So that's the reason for setting the AN select all to 0, because that puts all the ports associated with the analog to digital converter into digital mode, where you just flip them high and low. So that's what we needed. And then pretty much everything else is pretty much the same. And like I said, there was a problem. I noticed that I hope none of you ran into that. If so, then I've got it fixed now. But the code link was kind of messed up. And for some reason, I don't know why it wouldn't, the media file that I set up, it wouldn't show the code that I posted on this project. But it is fixed now. If we go back to my channel, it is fixed now. So there's the project code link. You should be able to just click on it, and then it should be right here, less than 16 timers. You should be able to download that, and like I said, it'll have the schematic as well as the code and all the stuff for you. So anyway, so there's all that for you, and it's the new updated code that has all the stuff in it. Oh, and another thing that I had forgotten was setting our config registers and setting up the clock. What we did here is I just set memclear to on, which means we're using our memclear. Remember that resistor that ties it up, and then we're turning off watchdog timers. We're turning and this FOSC internal says that we're using the internal clock, the internal oscillator, and by default that one is 4 megahertz. You can reset it, but I didn't want to set it for anything different. So what you do in high-tech C with this define extol frequency, what that is you're basically, this does not, I had a misconception on my part when I first started playing with high-tech C. I thought this actually set the clock speed of the internal oscillator. It does not. Just so you guys know, it does not set it. All it does is define it, and what this define is for is when you use any type of delay, like down here, this delay MS. When you use this actually is a function of this. This whatever you define here is how it's going to calculate milliseconds. So if you actually define a clock or you use an internal oscillator, and the internal oscillator by default is, let's say, 8 megahertz instead of 4, then your timing is going to be way off, because you're going to put, you're thinking that it might be 4 when actually its default is 8. So you could be off. So make sure, and you just got to read in the data sheet. The data sheet has that in there. It's under well, in fact, I might be able to show it to you. It's in the timing. It's it's when it talks about the oscillator. See if I can find it real quick. Yeah, special functions of the CPU, and then you've got the oscillator configuration. There we go. And see, here's where you can see, let's see, oscillator configurations. Here's where it'll pass through select for crystal oscillator. See, it shows you what the oscillator circuit looks like, and then it gives you the different frequencies you can set. And then I think there is a register, if you keep on going. I don't know. There's a register somewhere around here. No, this is brown out. There's a register that you can set. I'd have to, sift through this, but where you can actually set the clock speed. But in here, it'll say in this region, it'll talk about what the default is 4 megahertz for this one, for this chip. And so anyway, so that's where that comes from. So remember that this does not set the actual clock oscillator, the internal oscillator. This configuration bit tells it that it's not going to use those 2 pins. Let's see, where are we at? Device overview. It's not going to use these 2 pins, these 2 oscillator pins. It's going to use the internal oscillator. See, it even shows that on the block diagram. It's basically going to ignore these and just use this to pull into the timing generation. It's what it's going to do. That's what that configuration bit, FOSC, internal RC, IO, that's what that means. Is that that's going to use the internal oscillator, and you are not setting the internal oscillator, you're just defining what oscillator setting you have chosen, so that way if you use any delay functions or whatever in that function, it knows what your frequency is that you're running. So what you do is that, like I said, if you want to actually change the internal oscillator, you have to change it in a register, and I can't remember the name of that register right off the top of my head. You have to look in that one section of the data sheet for it, and then you'll be able to find what register it is to program. And yeah, and then in high-tech C, oh, that's another thing I'll show you guys real quick, is that I'll show you where to find your header file, or basically where all the defined stuff is for a particular chip. What you're going to do is you're going to go into your high-tech C software folder, in the pick C folder, and then check the certain version, and then in the include folder there'll be a whole ton of files, and like for us, we're using a PIC 16F676. So you're going to scroll down till you find PIC 16, and then you're going to say PIC 16F, and we need the 676. Now I'm just going to open it with whatever comes up, which looks like it's going to be Visual Studio. Okay, now here's where all your defines are, and see, so for config, it's config, and then see, here's where you get your FOSC, and it tells you, it gives you good comments of what this does. And so you can scroll down through here and you can actually find all the different designators. So like AN select and SEL is in here, and see, there it is, there's that register. And see, then it shows you what all the bits are. The bits are actually defined, so you can actually call out the exact bit and set it if you want to, and all that fun stuff. And so anyway, so that's where you find that. That's basically, so anyway, so in your program files, high-tech C, PIC C, the version you've got, and then the include folder will have that header file. And this is the header file that is called through the htc.h header file when you do it. So that'll give you, I've used that little kind of trick going and finding that file a lot, because sometimes what's nice about the high-tech C is a lot of times whatever it says in the data sheet, it correlates. So if it says ANSEL in the data sheet, that's what it's going to be in the coding. But sometimes it's not. So you want to take and try doing it just straight away, putting in whatever the data sheet says, and if it doesn't work, go consult that file. Go find that file and consult it and see what it actually is. So anyway, well guys, I've kind of rambled on long enough. Hopefully you found some good information. That ought to be good for now. Look forward to the future. We're going to be doing some stuff with, we'll do RTCs next. I may do something with capacitive touch using high-tech C. I'm getting quite a few different comments and whatnot wanting to see what the high-tech C code looks like for the capacitive touch sensing, so I may dig that old demo board module out of mothballs and write some code in high-tech C for you so you can see how that works. So anyway, well guys, that's pretty much it for this time, so continue coding and have fun with it, and I will talk to you. Oops, look at this. I found a mistake right there. Too many semicolons. I must have accidentally typed one. Anyway, well have fun guys, take care, and we'll see you later.